Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning platform. My name is Buno, and the subject for us is mathematics. The topic we will be considering right now is algebraic processes. And under algebraic processes, we will be looking at linear equations, word problems involving linear equations, linear inequalities, word problems involving linear inequalities. Then we will look at change of subject formula. Change of subject formula. To begin with, what do we mean by equations or linear equations? Linear equations. First of all, an equation is a mathematical statement. An equation is a mathematical statement that shows equality between two different expressions. An equation is a mathematical statement showing equality between two expressions. That is to say that for a statement or a mathematical statement to be called an equation, that sign of equality must be present in that very statement. So, if I say two x plus 6, this is not an equation, it is an expression. But by the time I put equals 16, it becomes an equation, because there is an equality sign, and now there are two expressions on both sides of the equality sign. And of course, 2x equals 16 minus 6, 2x equals 10, x equals 10 over 2, x equals 5. I believe this is simple enough. This is a simple equation, and of course it can be resolved simply. However, we will look at a few equations that will require a little bit of complexity. Now we have a question before us. We are to simplify this equation. Now, to help you a little bit, there are several ways we could resolve a mathematical equation or a problem. We can decide to add a number to both sides of the equation. We can decide to subtract a number from both sides of the equation. We can decide to multiply both sides of the equation with a particular number. We can also decide to divide both sides of the equation with a particular number. Now, if we look at this problem on the board, what we are having here is a case of fractions. But if you look very well, more clearly, you will see that these fractions all have a common LCM. That is, there's a for the denominators, there is a common there is an LCM, okay, that serves the three terms, or the three denominators that we have on the board. and that LCM simply is 12. So since we have 12 as our LCM, and that 12 is on the very last term, we can decide to simply multiply through the terms, okay, with the LCM. And by the time we do that, all the denominators will vanish, and then our equation will become simpler to solve. So when we say 3x over 4, okay, we multiply by 12 minus 12 times 7 over 3 equals 12 times 17 over 12. Of course, 4 will go here to give us 3, and 3 will go here to give us 4. 12 will cancel out 12. Now, when we simplify further, we'll have 3 times 3x. That will give us 9x minus 4 times 27. 4 times 7 will give us 28, okay, equals 17. So we can see that we have a very simple equation, and we can simply go on to resolve. So 9x, by the time we subtract 28 from both sides, or we add 28 to both sides of the equation, we will have 9x to be equal to 17 plus 28. Of course, you can say you add 28 to both sides of the equation to cancel its effect here. You can as well say that you move 28 over the equality sign to the other side, and of course the negative sign changes to positive. And so we have now that 9x becomes equal to 45. And so x becomes equal to 45 divided by 9, and x becomes equal to 5. It's that simple, right? And we'll look at one more question, and then we go to solve a word problem involving linear equation. Now here is another problem, and don't get it twisted, it's just about the same as the problem we just solved. Okay, fractions also, and however it's a little bit different from the one we just solved, okay, being that our LCM here will be a little more complex than the other one, okay. Definitely the LCM here, since we cannot pick a particular term for our LCM, we will have to pick an LCM, okay, by multiplying both denominators. So if we are to pick an LCM here, our LCM will be equal to x multiplied by x minus 3. Now when we take this LCM, we'll multiply both sides of the equation by that LCM. Simple process. We take the LCM, multiply both sides of the equation by the LCM. And what does that do for us? It simply vanishes the denominators like before, and then the equation becomes simpler to solve. Let's look at it. So we say x into x minus 3, okay, multiplied by 2x plus 5 over x equals x into x minus 3 multiplied by x over x minus 3. Okay, in this case, this x, okay, we'll cancel out this x, while x minus 3 will go with x minus 3, and so we'll have x minus 3 into 2x plus 5 equals x into 2x. Of course, when we open up the brackets, we will have 2x, x multiplied 2x, we have 2x squared, x multiplied plus 5, we have 5 plus 5x, and then 3, or rather minus 3 multiplying 2x, we have minus 6x, minus 3 multiplying 5x, we have minus 15 equals 2x squared. I hope there is no ambiguity here. Okay, x multiplied 2x to give us x squared, x multiplied 5 to give us 5x. There is plus here, so of course plus stays here. Now minus 3 multiplies 2x to give us minus 6x, and minus 3 multiplies plus 5 to give us minus 15. Of course, x times 2x gives us 2x squared. And so let us collect like terms. We collect like terms, we say 2x squared. This x will bring it over here, okay, and the sign changes as it crosses the equality sign to a negative term, or to negative, and then we have x plus 5x minus 6x. Okay, that gives us minus x. Now let's move 15 over to the other side, okay, since that's the only expression that doesn't have a variable. Variables, okay, here the variable here is x. 15 doesn't have any variable, so we can simply take it to the other side of the equation, and when minus 15 crosses to the other side, it becomes 15 positive. Okay, and so of course this is plus 2x squared minus 2x squared, so both cancels, okay, and then we are left with minus x equals 15. When we multiply both sides of the equation by minus 1, our answer becomes x equals minus 15. Can you see that life is simple? Very simple. So that's our final answer. Now we'll look at what problems involving linear equations. Okay, so right now we have a word problem on the board. Word problems are not as difficult. Word problems are not as difficult as they may seem if you follow the right steps. The first thing to do is to pick a letter, an alphabet, okay, that will represent the unknown, that will represent what we are looking for. And when you pick that letter, stick with it throughout the solving of the problem, and then go on to relate that letter to all the other terms and all the other words, okay, and problems as may be stated in that very question. Now we have, the question says 1/3 of a number added to 4/5 of itself is equal to 17. Find the number. 1/3 of a number, okay, we don't know the number, but we are told that 1/3 of that number, when we add it to 4/5 of that same number, okay, 4/5 of that same number, the result is what? 17. And we are asked to find the number. Now, we don't know the number, so we can call the number x, okay? We simply call the number x. Now, 1/3 of the number, 1/3 of x is what? One third of x is equal to what? 1/3 of x is same as 1/3 times x, okay? In order not to make it ambiguous, we can simply say 1/3 of x is the same as x over 3, because when you multiply 1/3 by x, it will give you x over 3, okay? What is the other statement there? It says 4/5 of itself. 4/5 of itself. By the time we add 4/5 of that same number, okay, to 1/3 of the number, our result will be 17. Now, what is 4/5 of the number? Four-fifths of x is equal to 4x over 5, or you can say 4/5x. 4/5 is 4/5, okay? So when we add both this and this, we'll get 17. So we say x over 3 plus 4x over 5 equals 17. Now this becomes our equation, our mathematical equation. This is a statement, okay, or word problem, and we have been able to reduce it to a mathematical equation. Now, just as we have done in former times, we have a fraction here, we have a fraction here, so we get the LCM of these denominators and we multiply through the equation on both sides by that LCM. What is the LCM of 3 and 5? The LCM of 3 and 5 simply is 15. So when we say 15 times x over 3, okay, plus 15 again times 4x over 5 equals 15 times 17. And so, of course, 3 will cancel 15 to give us 5 here. 5 will cancel 15 to give us 3 here. So we have 5x plus 3 times 4 is 12x to be equal to 15 times 17. 15, 17, that's 35. Okay, we carry 3, 7, okay, that's 10, and that's 5, and that's 1, so that's 2, 5, 5. Okay, and we have 2, 5, 5. Okay, 5x plus 12x is simply 17x equals 2, 5, 5. Not so? That's it. And so it's very simple to know that by the time we divide both sides by 17, our answer will be what? 15. Yes, our answer has to be 15 because it was 17 that multiplied 15 to give us 255, and the same 17 here is dividing 255. So our answer, which is the final answer, is 15. So the unknown number, okay, that number which the 1/3 of it was added to the 4/5 of itself to give us 17, that number is what? 15. So we'll solve one more problem. Now the question says, a man is 4 times as old as his son. In 4 years' time, he will be 3 times as old. What are their ages? A man is 4 times as old as his son. In 3 years from now, the man will be 4. In 4 years from now, the man will be 3 times as old. What are their ages like right now? So we will say that we can begin by saying let the son's age equals A. Yes, I want to use A to represent age. Okay, so if the son's age is A, we are told that the man is 4 times as old. So the man is 4 times A in age. That is it. Now in 4 years' time, he will be 3 times as old. Okay, we have picked the son's age as A and the man's age as 4A, since he is 4 times as old as his son. In 4 years' time, we will be the son would have added 4 years, okay, to his age, and also the man would have added 4 years to his own age. So in 4 years' time, we will be having son's age as A plus 4, and man's age will be man's age will be 4A plus 4. Okay, but that is not all. We are told that in 4 years' time the man will be 3 times as old as his son. Okay, so when we bring when we write the mathematical equation, okay, it will be that the man's age, which is 4A plus 4, will now be equal to 3 times the son's age. Does that make sense? We are told that in 4 years' time, in 4 years' time, he will be 3 times as old as his son. Okay? So in 4 years' time, 4A plus 4 will be equal to 3 times A plus 4. So when we expand the brackets here, we'll have 4A plus 4 to be equal to 3A plus 4. Okay, sorry about this. Okay, when we open up the bracket, we'll have, when we open up this bracket, we'll have 3 times A will be 3A plus 3 times 4 will be 12. Good. So when we now go on to collect like terms, let the terms with the variables stay to the left and the terms without the variables stay to our right. So we have 4A minus 3A will be equal to 12 minus 4. So A will be equal to 8. You see that? So clearly the son's age is A. So son's age equals son's age, which is A, is equal to 8. Therefore the man's age which is 4A will be equal to 4 times 8, and that should be equal to 32. Okay, so son is 8 years and the father is 32 years old. And with that, we have touched on the basic principles of solving a word problem. Take this and you'll be able to solve as many word problems as possible. Now let us look at linear inequalities.